Next is attenuation. When we use this term attenuation, we are referring to slight energy loss. So how to explain this? The loss of strength of the signal during its propagation through the transmission medium is called attenuation. So attenuation means the loss of strength of the signal, that is the power of the signal. Now amplification, when we use this term amplification, we are referring to that input signal has a low amplitude and output signal is to be amplified. So amplification means increasing the amplitude of the signal. If the signal is in the form of audio frequency, then if amplitude is increased, it means its loudness is increased, because loudness is directly proportional to amplitude square. However, loudness is directly proportional to area square of the receiving end. So I will elaborate amplification now. It is a process of increasing the amplitude and hence the strength of electrical signal. So if there is attenuation, there is a loss of strength of the signal, we have to amplify it. That's why amplification is necessary for a signal. So amplification is required to compensate for the loss of strength of a signal during its transmission. The additional energy is obtained from a DC source, direct current source, in which the waves are coming, which are moving unidirectional. Now we come towards the range. That is the range of a signal. So it is defined as the largest distance between the source and the destination, that is transmitter and receiver, up to which the signal can be received with sufficient strength. So the largest distance will be the space communication. That is, we make transmission from Earth and it is to be recovered in the space or by the celestial bodies. So what I think personally is that the range afterwards will be utilized to locate the intelligible or intelligent beings in the space. So it will take some time in the research. Now comes the bandwidth. Bandwidth means which is accommodating a lot of frequencies during the broadcast. It refers to the frequency range over which an equipment operates, or the range over which the frequencies in a signal vary. So there are a lot of frequencies in a signal, they vary, and that variation in the frequencies constituting the bandwidth. So during every broadcast, there must be a bandwidth which will accommodate many frequencies. And now we come towards the baseband. It refers to the band of frequencies of the original signal, a signal not changed by modulation as is produced by the source of information. Next is about modulation. Now modulation, as I have explained earlier also, modulation is a phenomena of superimposing the audio signal in the form of electrical signal on the carrier frequency or the radio frequency. That is what the meaning of modulation. And the modulated wave is the mixture of electrical signal and the carrier signal. Another thing which is important, that is the audio signals normally vary from 20 Hz to 20,000 Hz, and whereas the carrier frequency is about 10 to the power 13 Hz, and their wavelength order is about 10 to the power minus 5 meters. So that is what the carrier frequency, and the speed of the carrier frequency or the radio wave is about 3 into 10 to the power 8 meters per second, and this speed we calculate by using the Maxwell's equation, which is 1 over square root of epsilon naught into mu naught. This we have already discussed in the earlier chapters. So now we come towards the main concept, that is modulation. It is a process in which amplitude, the frequency or the phase angle of the high frequency carrier wave is varied. So it can be amplitude modulation, it can be frequency modulation, or it is a phase angle modulation of the high frequency carrier wave. So actually these amplitude modulation, frequency modulation or phase angle modulation, they are all related to carrier wave. The carrier wave is nothing, it is simply a radio wave But radio wave itself has got a broad spectrum. So carrier wave is a selected frequency which carries the signals. It is varied in accordance with the instantaneous value of the low frequency information signal. That is called the modulating signal. Now we come towards demodulation. Demodulation is carried out at the receiving end. So demodulation is carried out. That is, it is exactly the same phenomena that a person is moving in a bus. When bus reaches to a destination, then bus will remain outside the house, whereas a person will go inside a house. So, like this, the modulated wave, when it comes to the receiver, the antenna will receive it, and then there are certain components like PM junction transistor and PNP transistor. So, junction transistor has tendency of demodulating, that is, separating the audio signal and the radio signal or the carrier frequency. The carrier frequency or the radio signal is rejected back to the atmosphere, whereas the audio signal is fed into the transistor, where that signal gets amplified and passed into the loudspeaker, where a loud sound is generated according to the concept that loudness is directly proportional to amplitude square. Now, we come to the process of recovering the original information signal from the modulated wave at the receiver end is called demodulation or detection. It is the reverse process of modulation process that occurs at the transmitting end. Repeater. Now we come towards the concept that is repeater. A repeater is a combination of transmitter, an amplifier and receiver, which picks up the signal from transmitter, amplifies and retransmits into the receiver. Now at that time the receiver will be human ear, because human ear will be used for listening that signal. So sometimes with a change of carrier frequency, multiple repeaters are placed at suitable distance along the transmission path. This extends the range of communication system.